Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list published on July 22, 2025, just yesterday. This paper introduces a new system that gives large language models virtually unlimited working memory and allows for many tool calls within a single inference. The paper is titled Beyond Context Limits, Subconscious Threads for Long Horizon Reasoning, and as we'll see, this approach dramatically improves how models handle complex, multi-step problems. The authors propose a new model and a runtime that structure reasoning into trees, not just straight lines of text. Alright, so to visualize this difference, the first figure really helps. On the left, you see the traditional approach, a linear chain of tasks. Here, the model has to pay attention to every single previous reasoning token, which gets very expensive. But on the right, we see the new tree structure. After subtasks are complete, their results are combined. This new system then prunes the detailed key value states, which are essentially the model's short-term memory for that subtask, keeping only the summary in its working memory. This structural approach frees up significant computation and memory. Building on that tree structure, this next figure shows us the blueprint for how it all works. On the left, we see the recursion hierarchy. Recursion is basically a process where a task can call on smaller versions of itself to solve a problem piece by piece. You can see here that each task can contain thoughts, tool use, and even a list of its own subtasks. This is how the model breaks down a huge problem. Then on the right, the tool use schema defines exactly how the model can use external tools, like a search or a web reader. This structured approach is the key. Okay, so this diagram gets into the nuts and bolts of how the system manages memory during a task. We see how a main task can spawn subtasks, which can spawn even more subtasks, creating that tree we just talked about. The key mechanism here is called pruning. Once a deep subtask is complete, including any thinking or tool use, its detailed working memory, which is stored in what's called the key value cache, gets removed. Only the final conclusion is passed back up. This constant pruning is what frees up resources, allowing the model to handle incredibly long chains of reasoning. So this new system doesn't just manage internal thoughts, it also overhauls how the model uses external tools. This diagram compares the old way with the new TimRun system. On the left, with a traditional inference runtime, which is the engine that runs the model, you can see a lot of back and forth. The client, maybe an app or another agent, has to keep resending the entire history plus the tool's response back to the model. Those red arrows show this redundant processing. But with TimRun on the right, the tool's response goes directly into the model's memory. This direct path means each piece of information is processed only once, saving a ton of computation. Alright, so we've seen the efficiency gains, but how does this all translate to performance? Well, this table gives us a clear answer on the Data Commons QA benchmark, which is a question answering task. We can see that Tim and its predecessor thread dramatically outperform other methods like reflection or decomp. The most impressive part is that Tim achieves this top accuracy without any task-specific few-shot prompting. Few-shot prompting is basically when you have to give the model a few examples to guide its answer. The fact that Tim doesn't need this shows its inherent strength at reasoning. Moving on to some challenging math and STEM benchmarks. This table compares the Tim model running on a standard system called SGLang versus the new TimRun system. What's really striking is that accuracy stays pretty much the same, and in some cases, like the AMN 2024 task, it actually improves with TimRun. And look at that last column. It shows the percentage of the key value cache, the model's working memory, that was pruned. TimRun is freeing up over 50% of the memory, so the model performs just as well, or better, while using way less computation. So, to wrap things up, the big takeaway here is a fundamental shift in how we can get LLMs to tackle complex problems. Instead of treating language like a long, straight road, this new Tim and TimRun system organizes reasoning into a branching tree of tasks and subtasks. This structure, combined with smart memory management that prunes away old information, lets the model perform incredibly long and complex reasoning, maintaining high accuracy while using far less memory. It's a really elegant solution to a major bottleneck in AI. That's all the time we have for this week's AI Research Roundup. Thanks for tuning in, and I'll see you next time.